Good evening. For those of you working on method of sections, I'm going to go through this one here with a slight caveat that this is kind of given with showing two fixed moments here. So what we're going to do is we're going to right away change that so you don't get confused in terms of what you have to do in terms of reactions. And we'll start inking, and what we'll do is we'll put actually a pin joint here and a pin joint here, and then we'll discuss how the fact, because this is a truss, even though you've got a pin joint, you know the reaction has to be there or backwards. So we know that we can go about solving the reactions, and then we'll finally point out here in this depiction how your eye doesn't necessarily, with a 500 newtons, if you're smart, you don't necessarily need to pull this down, but it's not a bad idea. And the same thing here, to pull this down, it's not a bad idea. However, this one you almost do need to pull down with your eye when you're starting to solve for reactions. And you pull this one down with your eye because you want to break it up into a component that way and a component this way. This one having no moment about 0.4, and this one having, yes, in fact, a moment about 0.4. And realizing, once again, you see this kind of problem thrown at you with a 45 degree, and so you can realize that in effect this is a 1 square root of 2 triangle. Alright, that said, first thing, the question of how to use method of sections is really straightforward. Once you solve for all the reactions, even though you don't need to, you can cut any three members, because you know the direction of force within those members is tension or compression. You know they have no shear, and you know that in fact they have no bending, and so it makes it pretty straightforward. And so we will do that here through these right here, and when we cut those three, we do not need to solve for reactions, but we can solve for reactions if you want right now by using the kind of more or less rule, or because some of you are fixated, and it's a good thing to be fixated on, the sum of the moments about 0.4 is equal to 0, and those of course are equal to, we'll deal with the first one, in a negative direction, 500 newtons times this distance 3, and that is causing it to spin into the board or negative, and then the other minus 500, this times 6. And now this one, you could think about it as being force times orthogonal distance, but you're much better off realizing that this one here has no moment and this one does, and that you have here the cosine of 45 degrees, or you know that each of these should be 1000 divided by the square root of 2, I believe. And so if we take the square root of 2, we know we have somewhere around, and I'm going to hit and pause here, and downstairs without my calculator, but I'm going to hit a pause and get you that number, so we can then finally tell you that in fact we don't forget about the reaction here, that we're going to say plus the reaction at 1, right, and that's spinning positively, times this 3 meters, and we'll solve for the reaction at 1. One other way to think about this, of course, is just to say that this has to resist this, so it's going to be 500. It has to resist this, so it's going to be another 1000. And it has to resist this, so it's going to be 3 times whatever this y component is. So let me hit the pause here and see what that's going to do for us. Alright, we should know this by now, but if we break this up into components, in effect we do have something around 709, not 709. In other words, 1000 divided by square root of 2 divides it to 709 aside. This of course is going to be divided up in a couple of different ones as we go about right now. We're not going to see it here, however, because it is not spinning. Its line of action is going right through there. So we say, finally we say, this is also negative 709, and this thing, it's of course times, instead of 3, 6, it is 9. And so we know this is going to be 3 times 709, and that in fact is what this is pushing out that way with. So we're going to solve for the reaction at 1. That reaction is going to be equal to, it is 3621. Of course, this, I was wrong on this. This is actually 707. We should recognize that. So that is our reaction. In this case, if you think about it, it has to be a reaction. It has to be positive. Now, we did that, of course, by showing that this could have, what, 2 reactions here, a hatch and a hatch. We also do it a little bit by logic. So we can also now do the sum of the moments about 0.5 equal, about 0.1 being equal to 0, and we have the same general effect. Now we have, but in this case, the moment here is going to have, actually each of those components is going to have a moment. So we have the sum of the moments about 1. We have once again the 500 times 3, and it's still spinning in a negative direction. Again, 500 times 6, also in a negative direction. We also have then the 707 times 9 in a negative direction. And we then also have then minus the 707 again, this time spinning negatively times 3 again. Since it's up here, it's the one that's line of action goes this way. And we know, in addition, we then have, if we're showing this reaction going in this direction, minus the reaction at number 4 times 3, right? And that's the reaction at 4 in the x direction. The reaction at 4 in the x direction, because the reaction at 4 in the y direction, of course, is going to go right through that point, so it's going to have no effect on the moment. So solving for the reaction at 4, we get this, and before we do, we have to realize it is going to be pulling back this way. Since this is spinning here, it's going to be pulling back with 500. So this is spinning twice as wide, it's going to be pulling back with 1,000. And once again, it's going to be pulling back with 3 times the 707, which is in the y component. And then, in effect, it needs to be spinning back with an addition 707 because its moment arm is the same as this one here, and that, you see, is how we end up with picking up that last component. So we get a reaction force here as 3621 actually plus 3621 coming back the other way plus 707. So I'll do that. 3621 plus 707. And our reaction force the other way is 4328. So the reaction at 4, zipping around here, is in fact 4328. Reaction at 4 in the x is minus 4328. And of course, the difference between this and this is the 709 coming that way. Alright, so now you've solved for the reactions, but again, remember, you didn't necessarily need to do it. You could have cut this right here and then started looking at a sum of the moments. So that's what we'll do in the next 10 minutes. We'll take a look at doing this the right side of this. In other words, we'll cut this structure right here. We'll be looking at the right side, but I will tell you, learning to practice to do reactions in this way is good training. Do them both by sum of the moments about both the supports, and then also do them by the logic of the spin, especially when you get forces that are straight up and down or left and right. Thanks for listening. We'll continue now with method of sections and then go to cables in this series.